Thank you all for joining us today. I'm happy to have with me Chris and Irena, and we are going to talk about the different data roles in industry and startups. I see that we already have some questions on the chat. Yes, okay. So I don't know if you can hear us now. Maybe we do a quick check.
Yeah, Chris, I also say hello.
Good evening, everybody.
Yes, okay, great. Thank you. Yeah, so before we start, I would like to say that we have the Q&A option for today. So if you would like, please type your questions there. All participants can see the questions that are being typed and can upvote the questions. And then throughout the presentation, we can have a discussion considering also your questions.
And I think that it is indeed the case that all participants are muted per default, so no need to worry about that.
Yes, only the three of us that you can see have the microphone on. Yes. Okay. Let's take off my hat. Okay, and also another note that we are going to be recording the session for today, so you can also check it out later on our YouTube channel. Chris, would you like to do the introduction?
Yes, can do. So hello, everybody again. I'm Chris Armbruster. I'm here, so to speak, to do the honors, if you so like. Mainly talking will be actually Dania and Irena. But I had a hand in creating it, and here's, so to speak, why. Why are we doing this stuff on data career, and not tonight specifically on the data roles? Why are we going to talk to you about what it means to be a data scientist, a data engineer, a data analyst, and perhaps also some of the other roles that you like? It's because obviously, as we all know, it's an exciting time. Things are moving forward. Companies are employing people. The field is growing. Actually, the field is growing very rapidly. And there are also certain kinds of opportunities that come with it. And here's one of those. Here's a description of the major opportunity by Jean-François Garnier. So as you can read for yourself, no matter who you are, self-improvement is key. And then it only takes 4 years of experience to become senior, or 5 years to perhaps even lead an entire institute or lead an entire team. And then the determination and discipline to improve is what is the deciding factor, according to Jean-François Garnier. So Jean-François Garnier is Canadian, French-Canadian, a serial entrepreneur in Canada, and together with Joshua Benjo, the founder of Element AI, a well-funded AI startup that was actually recently sold to a Californian company. And he's been in the field with his collaborators for quite a while, and he's also particularly known for his talent reports. So it's actually worth finding his own personal website on the web, and on that looking at the talent reports for 2018, 2019, and 2020, because it gives you really a good impression of where the field is coming from and where it's heading. And so the opportunity is that there's a lot that you can do that you have in your own hands, and to seize the opportunity or to make the most of it, of course, it matters how you enter the field and where you specialize. And this is really what tonight is about, and why I think we're lucky to have Dania and Irena with us, two rather experienced practitioners, both senior in their field, with a lot of experience in newer companies and startup companies that can take you through this. Next slide. So here you have a little bit about myself. I'm guessing that those that have registered will have access to the slides later. So you can find me on LinkedIn, or you see the LinkedIn link here. I initially did some data work nearly a decade ago while working for the Max Planck Society, a German research organization, in the rollout of their digital infrastructures. And we were then able to start with something known as log file analysis, so weblogs. Today, it's still an important field. Today, you would probably call it data analytics. And then I later returned to the field to direct a boot camp in data science. And associated with that is I've been kind of involved in these issues for a number of years. That's why I come from. And then on to the next slide. And I'm guessing, Dania, you will say, you're much better qualified to say a few words about yourself. So please.
Thank you, Chris. Thank you, Chris, for the nice introduction to today. Yes, I am Dania. I am a founding member of the AI Guild. I am a data scientist working with machine learning models for predictive analytics mostly. And I was before a bootcamp teacher, but I am in the data career since 2012. So I started as an analyst and then moved on to data science. And yes, you can also find me on LinkedIn, and I will make the slides of today available later. Next, we have Irena. If you can say some words about yourself.
Yeah, so I will be very short on this slide. Hi, everyone. First of all, there will be a slide about my career path. So I won't waste the time here. I'm former also data analyst, data scientist at Zalando currently. Otherwise, I'm a mathematician by education. And yeah, I live here in Berlin with my family.
Thank you. So an overview of the plan for today. So we start talking a bit about the AI Guild and the project of advancing careers in the data field. Then we move on to talk about the different roles and also then the different skills that each role requires. And last, we have some orientation slides. So I think we dive into the first topic already. So I don't know, Chris, if you would like to say some words about the AI Guild or if I should.
Yes, can do. Actually, all three of us that you see here tonight are early members of the AI Guild. In looking at the screen, you can also see that Dania and I are using a particular screen background, Zoom background, that promotes actually a major event series that the AI Guild is running called DataLift. So we started really from looking at each other, and this looking at each other is kind of like 24 people, and thinking that important things are happening around in the data field, but that somehow the practitioners are not coming together well. And it would be interesting to have them together, and it would also be interesting for the community to grow and understand how to promote the stuff, what is called here advancing AI adoption. And it's perhaps to do with the special European circumstances, if you so like. So Europe has plenty of startups, it has plenty of internet companies, but it doesn't really have any big players on the scale of the US or China. And with it comes a kind of delayed entry into the data economy, if you so like. And you can see this playing out at the moment rather vividly. So earlier today, Dania and I were discussing the fact that if you go and look at the German corporates at the moment, you can see that one after the other is signing a deal. So BMW now signed a deal with AWS, Deutsche Bank signed a deal with Google Cloud, Volkswagen signed a deal with Microsoft and Amazon, just to be sure and safe. To kind of get their internal data economy going. And we thought that under these particular European circumstances, it would be really important to kind of bring the community together. Then the community in Europe is super international. So it really comes from all nations of the earth. And you can see here today somebody, actually, so I have a German passport. Dania has a Brazilian passport. Irena, what passport do you hold at the moment? Macedonian passport, okay. It could have been that, and then many people have dual nationalities, and they really come from all corners of the world. And so one of the things that the AI Guild is also is really this international community, and we now have members on all continents. So we're growing, and we're trying to bring the community together and advance AI adoption. And if you'd like to find out more, you can through these addresses here. And then also, if you are a practitioner already, you can obviously join the community. Ooh, wonderful. So I haven't seen this slide before. So it kind of gives you an overview. So the AI Guild really has two planks. So you just saw the earlier slide about the community. Then I mentioned the Zoom background that we're using, that when you read it, it says deploy data analytics and machine learning. So we're really looking at deployment scenarios and use cases and how to make it work in companies. And there's one way is to productionize it, but the other way is actually to look at careers, to look at the people, to look at the roles, the teams, and how to build them. And there are things that we do, like the webinar tonight, just so to speak, generally for the practitioner community. And then there are things that we do for members only. And we're ramping up particularly the members only part at the moment. And the idea is that as a practitioner community, we can kind of accompany you from cradle to grave, although that's a bit much, but we can actually accompany you from the start of your career all the way to becoming a senior expert. I mean, Dania and Irena, you've been in the field for 6-7 years. So yeah, so we're here for the community from the start of the career all the way until you retire or beyond, so for a long time, and really supporting the career development successively through the stages. And actually, one final word on this. So we already have in the AI Guild community chief data officers. And a particular thing that I'm really interested in is I think the European data economy will really grow and come into its own when we find data people that are actually willing to step up as CEOs, yeah, to actually lead the companies. Okay, another one here. So what does that actually mean for you? Yeah, so what have we found out? We've been doing this for 1.5 years in the AI Guild, some of us for a bit longer. So what do we know? We know that the search for a first role may take some time. We also know that sometimes if you're looking to upgrade, so for example, if you're looking to upgrade from an analytics role to a data scientist role, it's easier inside a company. And it's easier inside a company than leaving a company and training or retraining and then. So, if you want to move, it's easier inside a company. We also know that the job market still is not that well organized, that job advertisements may be misleading. You may have had this experience that you think you're looking at something, you think, is this me? Are they looking for a unicorn? There are these famous job ads that ask for 10 years of experience in something that was invented 2 years ago. A particular well-known example is Fast API. It's like 3.5 years old now, and there were actually job adverts asking for 10 years experience with Fast API. Wonderful. And then, of course, also something here at the bottom that really also was important when we got started, i.e. that the role in real life, so the role that practitioners have in their companies, doesn't actually always match the expectations of the people coming in, and companies are often struggling to productionize data analytics, and out of this comes this issue that practitioners sometimes have the feeling that in their careers they're not moving forward but kind of like sideways or are stuck, and then you start wondering, is it me? And then at some point you realize, well, it's the company that's not really productionizing well. And so there are issues that we've looked at and that we've learned from. And one more. And then in working with the community and also in observing the market and, for example, running this event that's also been running for 1 year now, we noticed that one really important trend at the moment is the specialization and differentiation of roles. So right off the bat, at the moment, one can see that the market for analytics is growing fast, and in some sense is bigger than the scientist. And that engineering is becoming increasingly a focus because companies realize, oh, oops, my data pipelines aren't really working, or I don't even really know where all of my data is. So that's becoming a focus. With that comes the rising value of domain expertise. That's not just in Europe, but that's also, say, in the US. So in California, there was an event recently where they discussed this. This was rather interesting, where there was one of these famous professors from Stanford University who runs these CS courses. And he was looking at the project work, and he realized, for him, interestingly, but perhaps not that surprising, but for him really interestingly, he realized that on the project work that was done, that people who had a qualification in X plus were looking at machine learning had the more interesting projects than the straight computer science students. So he runs this like later in the studies, and half of his course members are Stanford CS department students, but the other half are people that come in from agriculture, engineering, medicine, business, you have it, all different kinds of domain. And he started noticing that these people really brought something through their domain expertise that made a difference to the machine learning, because they were interested in the technology, but they knew for which problems they were using this or trying to apply it, because they were doing something else too. And with this rising value of domain expertise and the need actually to deploy the stuff, we observed that the experimental phase with these POC plays is ending. You also see that actually with the large German corporates now signing big deals with the American players. Yeah, they're kind of tired of fooling about. And with that comes an increasing focus on deployment. And that then again reinforces the specialization of roles. Yeah, if you really want to deploy, then everybody who's on the team needs to be really good at the job that they do. Otherwise, you get a buggy product, and that's the last thing you want.
Well said, Chris. Thank you. Yes, then we move on to the data role specialization part of the webinar. This is the part where I speak most. So I start here with an overview. It's based on the paper published by the Google researchers called Hidden Technical Debt in Machine Learning Systems. And it shows all the different pieces that you have to put together in order to productionize a machine learning service from beginning to end. And I put some colors to tell you what are the data roles that are mostly responsible for each of the pieces on this puzzle. So for example, if we start with the blue one about data engineer, they are the data collection, data quality, and data pre-processing mostly. Next, we have the data analyst, which would be responsible for the analysis, for bringing in the business logic, and for A/B testing. Then we have the data scientist in red, responsible for feature extraction, parameter configuration, and online validation. We have in gray the machine learning engineer. Here, the overall infrastructure where everything is running, and also the configuration, monitoring, any kind of management tools, and also the resource management. Lastly, in green, we have the AI researcher, which here I put as the responsible for creating the machine learning models. So basically, the data scientist would be the person using the machine learning model created by the AI researcher. So if we look a bit in details, each of the roles and their tasks. So for the data engineer, the main task is to build and maintain the infrastructure for the data pipeline. That is, collect the data, clean the data, pre-process the data. For that, the main skills required are knowledge of distributed systems, databases, and software engineering. We have then the data analyst in yellow. There, the task is to have both business and data understanding to be able to report on what happens. So the skills here are descriptive analytics, SQL, statistics, and dashboarding and visualization tools. If we move to the data scientist in red, we have there the task to understand the business case and then to build features to train the models to address such use cases. So the skills here are similar to the data analyst, again, statistics, SQL, but also programming, for example, in Python or R, and then the knowledge of machine learning and or deep learning techniques. The machine learning engineer has the task to take that model trained by the data scientist and optimize it and deploy it to production and then maintain it in production. So for that, the most needed skills are software engineering, DevOps, and systems architecture. Then in the middle, we have the AI researcher in green. As I said already in the last slide, the task here is to build new machine learning algorithms and to find custom scientific solutions. So the skills here are mostly about research, so presenting at conferences and also writing their publications. So I have here one idea to explain these specialized roles. And if you can think about cooking with your data. So if you think about cooking, you have to have ingredients to cook. So the steps that are taking care of the ingredients, that is taking care of the data, are the ones in blue of the data engineer. So you have to sow, harvest, and then to prepare your ingredients. Next up, you have to understand what you want to cook. So for that, you choose a recipe. That would be, for example, the analysis step done by the data analyst. Next up, you have to use your kitchen utensils and try the combinations to the recipes in order to prepare your meal. That would be the ones in red, so feature extraction and parameter configuration, for example. And all of this is done in your kitchen space and with all the tools you have available in your kitchen. So that is like the infrastructure that is maintained by the machine learning engineer, for example. You have that infrastructure to be able to use your data and to prepare your model. And after you have your meal ready, you can do some offline validation. That would be a kitchen tasting. So before giving the meal to your customers. And the A/B testing would be to get some response on your model by your customer. So like an A/B testing, for example. Yeah, so to wrap up, the data engineer would process the ingredients at scale. So that would be processing the data at scale. The data analyst would check for quality of the ingredients and the recipes. That is, check the quality of the data and bring in the business logic to understand how the data fits the business. The data scientist is creating and using recipes to cook, that is, using the data to train models based on also the business use cases. The machine learning engineer takes the recipe and turn into many dishes that you can serve efficiently. So we're not talking here about a home cook. We're talking about a restaurant that has thousands, I don't know, millions of customers to serve. And finally, the AI researcher is someone that would build all the kitchen appliances, for example, building a microwave to make it available for the data scientists and data analysts. So before we move on to the next one, I see that we have already some questions. So I will check here. So
some questions were already answered by Chris, or at least one, but there is one that you can answer because I could already read it. If you want, I can read it for you. It's regarding the difference between the data engineers and the machine learning engineers. The question is, so Ankit is asking if the infrastructure is managed only by the data engineer, or is it shared also with machine learning engineers? So the question about the infrastructure.
Yes. So the thing that I didn't mention, so thank you for the question. And the thing I didn't mention is that this picture here, how I use it, the colors, is what would be very hard definition. So it is something that only a machine learning engineer does, for example, what is in gray. But in reality, or what we find in companies, is that the definition is not so set in stone and it's a bit blurry. So depending on the team you're working, you would find a data engineer, for example, taking care of the infrastructure. Yes. Sometimes you have also a bit of mixed responsibilities, let's say. So not always is that you find such a clear definition and clear separation between the roles. And this is something that we see every time that it's getting better and better. So it's getting more defined and the roles are becoming more specialized, but it's a very young field. So it's not always that it's that well defined.
Yeah, okay. So I think that this also maybe partially answers another question, which is about the spatial database roles and GIC. I have to say I had to Google this. It's a So geographic information systems, I guess. So geographic data. The question is, the person is doing, data, I guess, managing database which contains geographic data. Is there a demand about such roles, and where do they fit? Sorry.
Thank you for the question. So about geographic data, I don't have hands-on experience. I know that it is used, for example, in, well, when you think about geographical data, you think about maps and about navigation. So I would say that for autonomous driving, there should be some applications, but I do know some people that are specialized in this kind of geo-analysis, and they work in companies that do either routes for taxis or that do routes for delivery services. So you have to optimize the routes for the deliveries, or you have to optimize the routes for finding the best or the closest taxi for the person calling the taxi.
Yes, so I can basically add to that, that in the mobility sector and the transport sector more generally, you will find a lot of use cases for that. Something that got me thinking that I don't actually know is, for example, in Berlin, a company like Delivery Hero, I guess they would actually at the end of the day also need this.
For delivery services. Yeah.
For all kinds of delivery services. So there will be, so Brian, actually the interesting thing is that you bring a certain kind of domain knowledge already, right, around geographical data and actually databases that relate to this type of information. And then yes, your challenge is actually finding out which type of company you would like to work for that needs this type of domain expertise, and then that's a match.
And funnily enough, my team is also doing working with geographical data. So we do geo A/B testing. So you never know. I mean, I work in Zalando, so you might think that that has nothing to do with geographical data, but actually we do use it because the marketing is or could be geo-targeted, and then one can use this data and possible, so to say, information that is hiding within the fact that this is a geographical data. And we see some comment about insurance companies. So I think that the possibilities are endless.
I just want to ask if you have questions to put it on. I was not checking the chat, that's why I was confused. I was checking the questions on the Q&A session, and there you can even vote up some questions. And I would like to take a question that was voted up from Fabian Due. So thank you for the question. He's asking our opinion about the online courses on Udemy, Coursera, Code Academy, and etc. If we have any recommendations. So I can say that I have a formal education. So my background is applied math, and in school or university I learned basics of math, statistics, and programming. So I didn't use online courses for that. So I don't have hands-on experience. I do have experience with the Coursera courses and the deep learning AI courses for more specific machine learning and deep learning hands-on programming, let's say. And I find it very useful, but also I understand that it's a different usage of the courses, because I already have the background from programming, for example. I don't know if any of those is better for one that wants to start learning data science.
Yeah, I also agree. I think at the moment it's not clear if it's like something to just improve your current knowledge, or is it for starting from a scratch. But on the other hand, if somebody wants to start from a scratch, there are also not that much opportunities besides during boot camps or Coursera or other online courses, because I mean, at least in Berlin, only in the few years we see master programs in data science, for example, or similarly. So these are not that, these are pretty new. And I think it's always fine. And I think for someone who just wants to start, I think Coursera is a great thing. And yeah, Andrew in NG in general is a person who kind of also is very enthusiastic about AI and really try to educate everyone.
And he is really good at teaching. I mean, I took all his courses. So.
Yeah, exactly. So for me, so yeah, if somebody's about some like a 100% recommendation, then I would always go for Andrew NG.
Yes, that's true. Yeah, I did the first course I did in machine learning was his, and after that I did all his courses. So yeah, he's pretty good. Okay, I would like to answer a lot of the other questions that are here, but first I will hand over to Irena because she, on her presentation, she's also addressing a lot of the things that I see that you're asking about. So yes, here you go.
Yeah, so I just started reading the questions, but we can go back to them. I just have a very short slide as an introduction for myself. Just that you know my career path, and then we can go into details about all your questions about the various roles and the skills needed and the transitions and so on. So I just want to say that, yeah, similarly to Dania, my background is also kind of within the field. So I started programming already in high school. I was going to Olympiads in mathematics and in programming in Pascal and at that time. Then turned to then I moved to Russia to do my bachelor and master studies. I studied applied mathematics and computer science. So again, there was a bit of programming. There was a lot of mathematics and including applied mathematics and numerical methods and so on. But my main focus there was in my theses, in both my bachelor and master thesis, was digital signal processing. So this is where I already started kind of working with data, because it's audio or image data usually. And yeah, just not from pure statistical perspective as many people who are currently doing data science, but I came from the harmonic analysis world. And when I came here to Berlin in 2012, I did my PhD also in digital signal processing in harmonic analysis at TU Berlin. During my PhD, I was working in on a topic called compensensing. So that is basically also kind of L1 regularization. So it was already kind of machine learning with another term and from a different field with a different application. And when I decided to move to industry, I thought this would be super easy because I was already doing it. But it turned out not to be the case, because and this was one of my first, so to say, obstacles that I saw, that was the lack of practical experience on programming or computer science in general. And at that point, when I was applying, most of the jobs which were machine learning were, first of all, software engineering jobs, and I lacked that knowledge. I mean, I had it from my bachelor studies, but not in a practical level and not that fresh. And during my PhD, I was working mainly with MATLAB, which was maybe kind of a mistake because Python was already getting some popularity there. But I had an opportunity to join like a small club and rewrite all my code to Python, but unfortunately I didn't do it. But I was lucky to get into a company which has a lot of data. That was Air Berlin, the airline company. So that was for me a great opportunity to work with the airline data. But I was working as an analyst, and I think there was one question regarding the skills needed if somebody wants to work as an analyst. So I think the main skill, maybe I think also across all the domains. Dania will speak additionally about the particular skills and maybe also programming languages and so on. But I think SQL is one thing which is a must in any of the fields. And then at that point we were, and then since analytics involves a lot of reporting, then it's about some reporting tool. At that time we used a lot of Excel. Now it could be also Tableau. There are other options for reporting, but then yeah, one is the technology, which is changing, and one just has to constantly learn it, and the other one is the so to say, the basic understanding, the basic statistics, and yeah, the basic rules for graphical presentation of reports and so on, usability and so on. So yeah, finally then, yeah, Air Berlin collapsed, so many of you know, so then I had to search for something new, and I switched to Zalando, and I'm very happy for this opportunity, and also as just as an information, because maybe it's interesting for you. For me, the switch was maybe easy because at Zalando I started working on a topic about campaign, so our market analytics or reporting on the marketing campaigns, and this was one of my tasks at my previous job. So there was one connection, kind of domain wise, that I had some knowledge, and I think this was a helpful circumstance to get the job at Zalando. There I started working as an analyst, so similar task, SQL reporting and so on. But then after my maternity leave, I took the opportunity to move to a more technical role, which was actually my initial wish, so to say. So I wanted to work as a data scientist, but I took this long way, yeah, back to science. And now in my current role, we are doing, as I already quickly mentioned, geo A/B testing, but not the usual one about our webpage or something like this, but for our marketing campaigns. So we try to find correlated areas and figure out how our marketing attribution model is working. We try to improve it by predictioning our marketing, the behavior of our customers, and yeah, sorry. And try to improve the ROI at the end. So yeah, this was my journey, and here you see with small icons the tools that I'm using or we were using. As you see, again, is a data science. There are more software engineering skills, so to say, but we will speak about this also in details about the particular skills. So now I don't know if there is something else regarding my path, some question. Otherwise, regarding the skills, we can still talk about them in the other slides.
We have a question from Avish. So how can I work as data scientist with big company like Zalando or others? I have a knowledge of Python programming and I'm working as a student with startups.
Yeah, so I mean, so thank you for your question. So I think you can work at a big company just as anyone other. I don't know what's exactly is the question, like how you should get into the company, or you should, I think the most important is to find a job that will match your interest and your current skills and knowledge, just to be yeah, on the same page, so to say, with what they are looking for. Investigate a lot about the company, what are their interviews like. So if you ask for big companies, then I think the answer is pretty much obvious. Like my advice would be to read, for example, on Glassdoor, you can read thousands of interview questions, and then you see what are the interviews like. You can find people who work there and speak with them. So I think the best, your best buddy is preparation.
Yes, I second that. Yeah, because I think that you have to prepare for the interview when you want to work for any kind of company. You can, as you were saying, find information on Glassdoor or find people that already work at the company to ask them more questions, but really be prepared to talk about the company, so understand what they're doing, what are their values. I think it's important. Okay, I will go to the next slide. Yes, I have here in general for all of the 5 roles that we're talking about, I will try to describe them using the same framework, which is this T shape. So we have a T, which means that we have different or broad knowledge and some deep expertise. So for example, we're talking about Irena's experience as data analyst and data scientist. So I will start with those 2. So the data analyst, we talked about this, the most important skills are communication and visualization. So for that, you can use, for example, Excel or Tableau or any other kind of tools for visualization.
Yeah,
Combined
so there's a
with
question about this exactly, Dania, sorry to interrupt.
Yeah,
so yeah, I
please.
think the most popular dashboarding tool is Tableau, but maybe this is just at the moment. And I think on the other side, here in Germany, Excel is still quite used. Sorry, I think I have to get a glass of water, okay?
Yes, please go ahead. And I would say that Tableau is the most common one. At least I have worked with Tableau in 2 different companies. And yes, people also use Excel. The difference is that Excel, for using Excel as a visualization tool, you need to extract the data. So the other tools, for example, like Tableau or I think Quick View, is you can connect to the database directly. So you have data that is connected to the database and is refreshed and is maintained by the data engineering team, let's say. So you combine this with your data interpretation and the logical approach to be able to communicate the insights. And then it's also very important to have the domain expertise. So if you're working for a company in the marketing sector or healthcare, e-commerce, or any kind of domain. It's also important, like Irena already mentioned, to know how to get the data. So for that, you need to know SQL to get data from the database. If you know R and or Python, it could be also useful for visualization, for example. And also then to apply any kind of statistics, so descriptive statistics, to do hypothesis testing, and if you have the chance to apply any algorithms for classification or regression, for example. Then for the data scientist in comparison, again, it is important to have the domain expertise, so you know what is the use case that you're working with, and having a data interpretation and logical approach. But then on the programming and tools side, it is important to beyond SQL and R or Python to understand how to work with tools for coding like Jupyter Lab or Jupyter Notebooks, to know how to use Git to be able to share your code with others so other people on your team can also use your code. And the strongest skill or the deep expertise that you need there is really on machine learning algorithms and statistics. So here I just put some examples for Python libraries that you would use, like pandas, scikit-learn, numpy, keras for deep learning, and then the knowledge of probability distributions, regression and classification algorithms, and even deep learning algorithms. And back to Irena.
Yeah, so I was just scrolling through the chat once more to make sure that we don't have any missed questions. I found one which is regarding the switch from academia to industry. So what is the most challenging part? I think the most challenging part is to find your first job. After that, everything will be much easier because you already have one year, yeah, at least a particular amount of time of what people in industry call like a real experience. So I think that's one part. Another part, what helped me, for example, was to figure out and to understand for yourself and for your motivation and self-belief, so to say, what are your skills, what you have learned. So, and I think it's not always the hard skills. So I think on one hand, it seems like people from academia are missing some hard skill. So in my case, let's say software engineering skills or some other technical skills. But on the other hand, one has to be able to specify, so to say, or to put an emphasize on the soft skills that people who are coming from academia do have, which is very hard analytical skills, very hard problem solving skills, and most of all, a skill for learning fast. So I think this is also at the beginning of the webinar, Chris mentioned that quote, which says that, yeah, being able to learn constantly is the key in the whole field of data science. And if you were in academia, most likely you can learn fast. And if this is your case, so that you just have to convince the other people that whatever is out there that you don't know, you just don't know it yet. And you will learn it and you will be using it. And in 3 years, the tools will change again. You know, the point is that when you start with a company, 2 years afterwards, or maybe even 1 year, or maybe even half a year, and fast developing companies like Lando, for example, the tools will be changed in 80%. Everybody will be using just different technologies, but the people might stay, and then they will stay if they are able to adapt. And yeah, I think these are the kind of skills that you have to show that you possess, and then any transition will be easy. So yeah, regarding the books, I have to think about it, but yeah, I must say that I studied in Russian, and 99 or maybe 100% of all the books that we studied were in Russian. So I'm not sure if they're, I guess they are good translations, but yeah, but here I say, when you say statistics and mathematics, I think specifically maybe you need a book about linear algebra, because the basics of machine learning would be learning linear algebra. But I cannot say about about books really. And moreover, in Russia, usually you don't learn by books, but you learn by small scripts which are written by the particular professor that you are taking the lecture from. So yeah, it's a bit.
I did use books in English, but I don't remember. But if I find the name of the book, or if I can remember, yeah, but for sure linear algebra.
Oh, I know linear algebra. So there is one professor at MIT University who has a linear algebra, very nice book, and also a course, and his name is.
Oh, nice.
Okay, if you Google linear algebra MIT, I'm sure Gilbert Strang, I think. So yeah, maybe this is a good book for linear algebra.
Yeah, so when you have the understanding of linear algebra, I think the algorithms become easier to understand, or at least to grasp what is the idea behind them.
Yeah, so Strong linear algebra would be my advice.
And there's another question for you there.
Yeah, so the other question is like harmonics signal with perform autocorrelation of signal, correctional of the signals, some visualization techniques. I've already seen some of correlation. Would be great. Yeah, so I think for a particular good visualization, one would need to have to know the particular problem. I was working in a field of inverse problems, and usually the data or the application of this would be, if we're speaking about audio signal, would be about music. For example, if there are people in a concert, 3 people playing at the same time, and you have the music as an audio signal, are you able to distinguish the 3 instruments and separate the signal? So this is called the inverse problem, because if you have each of the 3 people playing separately, you can easily sum it up and play it as a one piece. But can you separate it back? Usually no, because if I ask you what's the sum, like I tell you 10, and you tell me which 3 numbers in sum give 10. There is a variety of possibilities. If I ask you how much is 3 plus 5 plus 2, this is one answer. but the inverse problem has multiple answers, and if you don't have some pre-information, then it's hard to guess. So yeah, I don't have a particular answer about the visualization of signals. I think this has to be in the particular question, what exactly do you want to see. Okay, so there is one more question. The underlying models are used over the years. Which concept ideas may stay relevant for 5-10 years in the future? Yeah, it's a good question. And here, I mean, indeed. So I think any basic model, if we are speaking about model, I mean, even something like linear regression surely will stay there for 5-10 years. I was thinking more about something else. I was thinking more about the technology. For example, the data, like at Zalando, the data was stored in a data warehouse somewhere locally, and it was a small amount of data, and you would query it just using standard SQL statements and so on. Nowadays, the amount of data that is produced is huge, and the data has moved to a cloud, so we use Amazon Web Services, and the way that you can even get this data is much more complicated. So this is what changes. Another thing is that previously, maybe more often, every data scientist would have their own Jupyter notebook with their own small model, and they will do something and redo it and test and then just produce their result. Nowadays, everybody's working on reproducibility of the code, deployment on a scalable level that can be reused and reshared and easily modified. So this is huge machine learning pipelines that can be then generalized, so to say. So this kind of things are changing, and this is where one has to keep growing, just not to get lost in like where is everything. I think on a paper, yeah, you're right. I mean, the mathematics is changing very slowly, but the technology very fast.
Yes, for sure. Hey, would you like to continue here on the slides about?
Maybe I think also this is what I think people are interested in, and then we can go back to the questions. This is just another slide about the differences. So not in terms of the particular technical skills. This is something that Dania already spoke about, but for me, this is more about so to say the behind or the profile of a data analyst and data scientist. But again, here I have one disclaimer. Really, if you look on the internet, it's a mess, and the job description is not always clear. There was also one question about data infrastructure. What does it mean and what it is about? I would say, I didn't answer it in particular, but I would say, I guess it's about data engineer, but you never know. And is it about building the infrastructure, maintaining the infrastructure? So again, it's a big mess, and one cannot be very general about this and come up with some rules. But in my understanding, and as Dania also spoke, we see data analyst as a more descriptive analytics, and then data scientist is about the predictive analytics. Although data analyst is used more generally, and sometimes the data analyst role would involve also very complicated machine learning model build up or something like this. But in my understanding, now I'm speaking here on one side about visualization, analytical presentation of facts and figures about the data, a lot of business knowledge, so to say, and then a lot of the people who are working in this field are not necessarily coming from a science world, so to say. They could be very well also economists or have business background. have only bachelor degree, and this is also pretty normal and enough, and this is good for the role. And yeah, and we spoke about the hard skills like the tools for visualization and basic SQL skills and so on. On the other hand, if we speak about data science, if we speak about predictive models, then more often people would have a PhD and have a background in mathematics or sometimes physics or computer science. Their work will be based on some complex mathematical models, and then the knowledge that they have usually is a bit broader and deeper. A lot of software engineering skills are required. And then here, yeah, on one hand, I think here there is nothing about good and bad, and it's very interesting. And in the last, in the previous webinar, there was someone who was in the kind of data science role and said, I actually don't like this because for me it feels like being a software engineer or a programmer, and I don't want this. I want to be a data analyst and I want to do reporting and visualization. So there's nothing about better or something like this. It's just different, and everyone has to find what they are interested in. And I think there is one kind of philosophical difference, that when you present the results as a data analyst, the data and the figure that you are working with, as long as the data is accurate, are facts, and you are just finding the nice way or trying to find the correct interpretation of them, or the highlighting the important parts about them. But you know what you are presenting is always true and it's clear, it's like this, so people can like it or not, but it's a fact. On the other side, when you are a data scientist, then the results usually come from a very complex mathematical model, and your people that you are presenting this to might not even understand that model. And then the results as well always contain a percent of error, because it's a it's a mathematical model, so it's almost never 100% accurate. So it's a question also how you present it and how you make sure that these conclusions are then correctly taken and then understood, and that you are also confident about them. So yeah, it's a bit of a question of knowing and feeling comfortable with the data that you are working with. Okay. Yeah, and this is then again maybe like a summary. Maybe I already mentioned this more or less, but yeah, since in my case, and I think it's the case also for many others, and there was one question about somebody wanting to transition from BI analyst to data scientist. So what does it require, or what will change? Or I don't remember quite well what was the question. But yeah, but the transition, what it will bring, according to my experience, surely, is that it will bring more software engineering tasks and needs for, say, upgrades. More mathematics and statistics, and but then maybe more conferences or even writing articles. On the other hand, maybe less participation in business decisions, less stakeholder management, and since there is less reporting, also usually less of manual work. But on the other hand, still one works with data, and data, we can have passion for it. It also brings us trouble. I think it's a kind of a myth to think that all the data is ideal and as good as the one that we see in the courses. Usually it's not, and to clean up the data might take a lot of time, and what remains at the very end in each of the cases is the ability to make data-based decisions. And I think this is the best part, because and as Chris said, we need more and more people that are CEO level and data driven. So I wouldn't say that they necessarily have to come from previous data scientists, but at least if they are knowledgeable about this and if they want to base their decisions on the results of data scientists, it's already quite a lot.
Yes. Thank
So,
you, Irena.
yeah, sure. I don't know if we have some questions left. Maybe Chris has a more overview.
Yes,
Why?
so hello there. As you probably saw, I've been busy typing since I didn't have to speak so much. And I've also discovered that in the Q&A, by going to the answered, people have responded back, and I'm now in the process of answering them some more. So in the Q&A function, you can click on not just open, but answered, and you can see more coming in. And actually, there are perhaps two that I responded to that you could also. So actually, Emily was the one who is the BI analyst at the moment and wanted to move into a data scientist. And then it turns out that she has actually experience with R. Now, Emily, you haven't said exactly how much, but I'm guessing quite a bit from what you've done there. And then I think this is an excellent stepping stone, but maybe you can comment on the relationship of R and Python. I mean, we know that companies these days typically don't work in R or don't work much in R, and you do need Python, but we also know that it's always been an excellent way to get in, right? So maybe you can say a bit more about that.
Daniel, do you want to say something? Or I mean, in my case, so I knew, I don't know, every programming language, but none in a professional experience. So this was my problem. And then, but I knew for myself that it would be easy for me to learn one more new programming language. And I don't know what's your case. Do you have in general, do you feel that you have a good base for understanding the principle of a programming language in general? Then you just take the other building blocks and the other language and you do it. Then I would say that I would apply even for jobs who require Python, but I would feel confident. But if it's on your only, so to say, and then also, do you know SQL? If you already know SQL, that's again another kind of programming language in some sense. And then for you the change would be easy. And again, sometimes it takes few, I mean, I don't know, just few sessions or few maybe very crash courses on Python just to get a feeling about it. And then it's a question, I think at the end it's a question of just if you can Google fast enough and learn on the go, if you are that type of a person. For me, this was one solution.
Yeah, and again, I would use my experiences because I learned the algorithm programming before I learned any language. And then in university, we learned C, and we worked with MATLAB and R. So MATLAB was for the linear algebra problems, and R for the statistics problems. That's what I knew. But when I started working, as Chris mentioned, yes, a lot of the times you are working inside a setup that already has Python, for example. So maybe the data pipeline is built in Python, or the final application is built in Python. And if you know Python, because it's a more general use programming language, then it's easier to connect your machine learning solution in that. On the other hand, I still use R to this day for predictive analytics, most specifically for time series modeling, because R offers more packages, or because it's more for researchers. So a lot of research is done in R, and then we have an open source package in R that we can use the algorithms from that research. So I think it really depends on what is it that you are building, or what is it that you need, that you would find packages in R or Python. But yeah, I think both languages are pretty similar. And also nowadays, a lot of packages are published in both, so R and Python. I would say that the advantage of Python is because yeah, most of the times it's easier to just integrate with another solution if, let's say, the data pipeline or the application, let's say the context that you are inserted in is already using Python, then it's easier to program in Python.
Yeah.
Otherwise, I don't think it makes a lot of difference.
Yeah.
Nowadays, you can build your own standalone microservice and doesn't matter what's there. And people just send you some request and you give back, let's say, the prediction. So it doesn't
Yeah.
matter if it's R or Python inside.
Yeah, yeah, but I think here I just want to add shortly. I think here Chris addressed the question even better, maybe because at the end it's not that much about the programming language, but if you want to be a data scientist without a previous experience, then I think the core knowledge is the machine learning knowledge, and this is something which is maybe even harder to get from scratch. And here, maybe one option, I think, if for someone with a very little or no experience in some machine, very good, so to say, base for machine learning and so on, would be to start as a data analyst and find for positions. Maybe there, I think there are often positions which are data analysts with a like a wish for machine learning. This is what I mentioned maybe previous in the previous also webinar. I think it's interesting to say that if you are doing reporting and you are good enough and you in technically that you can automate 85 or 90% of your reports, then you have a lot of time to play with the data. And I think the first start into becoming a good data scientist is maybe just yeah, make up problems and find time and play with the data and yeah, do so to say some modeling and experiment a bit with some things which are of potential interest. And then you can get experience, and then, as we also said, as Chris said, moving internally would be also possible. You could talk to other data scientists in the company and so on, and then you could transfer more easily. Because I think when I haven't checked the data scientist roles that are out there very recently, but I would say that usually there people are already looking for people who have enough experience, be it may only from academia or both academia and industry. Chris, do you know if there are some other? So we have 5 open questions.
Yes, maybe we can address the first one that was upvoted from
Yeah.
Eva. So thank you for the question. What do you think? How important is it to have a portfolio of projects to find the first data science job?
Oh, this is so tricky.
It's a good question. But the question is like, is this person a previous student or is someone who worked but in a different field?
Maybe Eva can write on the chat about this. But yeah, I think the question comes from the idea that, yes, you need to have the knowledge, and how can you show that you not only have the theoretical knowledge, but you can also apply those knowledge, right?
So we keep getting this question, and we also keep trying to answer it, and it's actually not easy. So there's some of these things where I kind of, from experience and from what I've heard and seen, feel more definite about. So something that I, for example, feel definite about is just because you're doing Kaggle competitions and you're maybe doing well of them, actually won't get you hired. And this is because I've seen hiring managers and even chief data officers talk of Kaggle in a certain kind of way. And also because I know some Kaggle grandmasters that have had troubles holding down their employment, so it hasn't really worked very well. So Kaggle in sense of projects, Then the other thing about the project or
Sorry,
the portfolio. Yes.
I just want to make an observation about Kaggle, because I think it is a pretty good starting point. So if you have just finished one online course and you want to test if you learned something or not, I think Kaggle is a good starting point, just for the fact that there are lots of data and problem statements there. So it's not just data, because you can also search for open data sets, for example. But then you also have to come up with the question, right? So there you have the data, you have the question, and it's a quick, fast way for you to test if you know what you're doing. And also you can see the other people's notebooks. So people that already posted the answers for that. I think it's a good starting point, but I don't think it's the portfolio for you to get a data science job.
Exactly. So the question is, you know, what gets you hired? Well, Kaggle competitions don't. I would be happy to say Kaggle competitions don't get you hired. Don't.
Yeah, I just want to amend that it's not trash just because it won't. But
no, that's not what I was trying to say, but it does get you hired. So next thing is, will a portfolio of projects get you hired? And then we know that, you know, if you do online courses or you go to a boot camp, you're often kind of encouraged to do a portfolio. And yes, I think, again, it's maybe beyond the starting point, it helps you to try yourself out. And maybe it also helps you to explain certain kinds of things. But I'm also guessing that if you do a project that is a time series analysis, and next you do a project that does NLP, and then on top of it, you do some image processing, it actually also won't get you hired, at least not currently. In a market that is a bit tighter, because you then have like a bouquet. But again, the question on the other side will be, well, so what the heck is it that you want to do, right? Do you want to be an NLP practitioner, or you want to specialize in time series analysis? And why the heck are you doing so many different things? Don't you know what you want to do? And I'm guessing that if you want to stand out at the moment in a slightly more crowded field, you need to clarify for yourself where you're heading. And then once you know where you're heading, whatever you do needs to pay forward to that destination. And then it becomes a convincing case. So I do think that projects matter, but I'm thinking if the projects were all in one domain, or if you could show how one project builds on the next, we're talking. Yeah, then we're actually talking. But otherwise, this bouquet of projects is something not well defined enough any longer.
Eva answered that she has a PhD in physics and has some machine learning and Python knowledge. So yeah, I think it's important to understand what is it that you are interested in, as in the type of machine learning you're interested in doing, for example, if it's NLP, and if you can find the domain that you're interested in and apply that knowledge.
And at the end of the day, I think maybe one reason why would someone do those projects is just to practice, because at the end, I mean, usually I think a big company would most likely never rely on the project that you have done anyway, but they will give you a project to do for the job. I mean, for the
challenge
process, yeah, exactly. So you get one challenge most likely, and you have some time to do it. And then, of course, the more of those projects that you have done, the more experience you have to do that project nicely. And then that might potentially actually get you the job. And sometimes you can use like knowledge from the previous projects to do this.
Yeah, I think that's why I think Kaggle is still a valuable resource in that sense, because it gets you practice. There are a lot of problems there, and with a lot of data, and also a lot of code written. So you can try to do some exercises there to get the practice on the stuff that you learned. I don't know if you would publish that in your GitHub as your portfolio, no? But it gives you a starting point. And from there, you can be more creative and start looking for other data sets. But you're right, Irena, most of the companies will give you a code challenge to really test in their framework. Okay, we have another question from Eva Agraval. So she asks, she's currently pursuing a master's in data science in Europe and have 5 years of experience working as SAP developer and consultant at IBM and Accenture. I have working knowledge of SQL, Python, large-scale databases, machine learning, and other subjects covered in the master's course. But I'm still having a quite difficult time in finding a master's internship since this position here in Europe. Could you suggest a better approach for this? Okay, no. Now I see that Chris asked for more information. So given the experience and the current degree, the skills are there. Yeah, I would say pretty much the same. It looks like you have the knowledge.
Yeah, so what's going on?
Yeah, I think it also depends on what kind of internship or what kind of master thesis you're looking to write. And I think that would pretty much help you in targeting the right companies. So for example, if you are looking for doing some thesis using or based on customers data, then you might want to go for an e-commerce because they have a lot of transactions. So you could look at that. So maybe if you think about it like that, it will become easier to target a type of company.
Yeah.
Yeah, we have another question. What is the difference between data analyst and business analyst? Who can do the role of the other? Irena, maybe you would like to take a
Yeah, I mean, it's a good question. I think maybe the answer is just most likely it's historically, I would say. In my experience, everyone was business analyst some 10 years ago. Now things are changing and some companies they're adapting, and then you have data analyst. And as I said also previously, maybe a data analyst is like I don't know, 80% of their time a classical business analyst, so poor reporting like monthly and quarterly and yearly reporting on the KPIs of whatever the company is doing. And then maybe 20% there is some kind of data juggling and machine learning involved in like yeah, in some way or the other. And then a business analyst might use zero, so to say, more advanced statistical methods. But sometimes it's really just historically, and sometimes maybe from one day to the other, the companies would change the name and then call the job. Now this job will be called data analyst. So yeah. I wouldn't restrict. So if you are looking for a job, I think this is very important to notice that if you are looking for a job, never restrict yourself on one particular naming. Even if you are looking for a data scientist, also Google the data analyst jobs and the other way around, because it's a really a mix. And if you're looking for a data analyst, then also Google for business analyst, because maybe you will even find your dream job under a very specific strange name, especially for Zalando. My first role was a commercial campaign analyst, and now my role is A/B testing specialist. So there is nothing about the data science. It's just the naming, but what's behind it's important. So yeah, there is a question about the how complex is data science. Actually, I'm a bit puzzled about the question because it says, yeah, data analytics is descriptive statistics, and then what is data science? Is it just Bayesian? Is it just linear logistic regression, but also or reaching to Bayesian statistics? I mean, data science is quite much more than even this, and data science can be no Bayesian, so not even trying to reach, because it can be coming. I mean, data science is like trying to find answers by looking at data. The methods that you are using might not be statistical at all. The methods might come from neuroscience, for example, might come from, I don't know, if you take tools like natural language processing or reinforcement learning, or also image processing, can use a variety of mathematical tools. And yeah, it can be quite complex. And how complex, I think that depends on how, I would say, data driven the company is. The more data driven the company is, maybe then the higher the chances are that they are using more complex tools. And
yeah, I think what you were mentioning before is that data analytics is more descriptive statistics and data science is more predictive statistics, or using statistics to build predictive models.
Yeah.
And yeah, I would agree with you that data science is about understanding the patterns in the data that is available to try to predict something. And you can use different methods to do that. So I think linear logistic regression can be one of the methods, but it can be more complex. Really depends on the data you have, depends on what is the answer that you're trying to get, can become really complex. Do you have more questions? Maybe we can answer. We still have 7 minutes before we.
So yeah, there's a question about the automation of machine learning models. I mean, tools, surely they are, but I think this is a very company specific if they are using pre-written models or you do it yourself. But I mean, even if there is, then somebody has to make that work.
Yeah, and I think a lot of the tools, what they try to, or what they are automating is really this idea of the hyperparameter search. So each algorithm has some parameters of the algorithm itself, the hyperparameters. And for that, you have a lot of strategies on how to find the best set of hyperparameters. So for example, if you're talking about a random forest, you have to decide how many trees you have, how deep are each of the trees, for example, and how many iterations you want to have on your algorithm and so on. And for that, you can try different strategies and you can basically program the strategies. So for that, you can do AutoML. What you cannot do with AutoML is understand what are the features you need to extract from your raw data, and also what is the target of your solution. So what is the metric that you're trying to optimize on? And in the end, what is the business case for that model? So those are all the stuff that cannot be automated. Still need a human brain to think about it. So I have heard a lot about this automation of machine learning models, and I would say that there's a lot more to the data science job than to just fit a model.
Yeah. There is a question about the German market, so maybe this is a hint for us to move forward, at least with the slides, because we.
Yes.
I don't know if there are some slides left for myself.
So I have 2 more slides. Yeah, okay. So I think.
Yeah, so I think this is something that we already said it all. Yeah. We mentioned, spoke about why moving internally is easier. Then, yeah, every analyst will have some time for himself to be his own data scientist if you have free time. And then, yeah, constant learning. I also mentioned this. And yeah, being active in the community opens your door. This is indeed very true. And I saw that somebody else has commented in the chat, and I thank myself also for that comment, that if you want to apply for some companies, try to find people who are working there, speak to them, even ask for them to recommend you, or speak to the people that you know, try to build up a network and then share the urge for a job. I think it's the best way to, first of all, is getting the job, if the not the mutual fit, and that's why it's a correct track. So I think might help you get the job of your dreams.
Okay, thank you, Irena. And the next 2 slides or 3 slides are about the skill sets for data engineer and machine learning engineer. I will share the slides with you after, and you can take a look in more details. And the last part of the webinar, or the last 5 minutes that we have, is about the data career orientation. And we have a very nice question. The Irena pointed out, Lockmanne, if I'm pronouncing it right. What about the German job market in this field for 2021? Thank you for the question. Chris, maybe you want to take over also for the slides?
I'm available. If you give me the next one, I'll say something.
Yeah, exactly this one about the German
answers. So
for the question.
About the job market in
the job market
this year, in the coming year.
So there are some number of things that we know that not just I know, but Irena and Dania, you actually also know from people that, so some of the things that we know is people are starting new jobs every month. So there are new jobs that are being filled every month. Something else that we also know is that at the moment, some people have been searching for a very long time. So the search times have increased. And we also know that the job market has become tighter. We also have seen that particularly for data science roles, the competition can be quite fierce, and that applicants have been told by companies, oh, but we had 400 applications, you know, so how about, so they weren't actually even able to consider most of them. Then we all are still living under COVID-19 conditions. There is light at the end of the tunnel with the vaccination, but that's how it is. There's also been this notion that COVID to some extent accelerates things digital, things data, which is true. But on the other hand, many companies have been cutting their budgets. So there's also less investment and also less investment in new things. So if you ask me in a nutshell, I think the labor market in 2021 will be difficult. It won't be as open and won't be as welcoming as it used to be. And I do think that if you want to have a sound start, you probably need to be more focused. You need to be clearer about what particular role in which domain you want to be and work towards that specifically. Because the thing is, and that's actually difficult because particularly when you're moving into the field, you think, oh, I'm moving into the field. How do I know who wants me? So you're kind of unclear about this. So there's this kind of temptation to keep your options open or to try and be wide open in your options. But the more you keep your options open, the wider you're looking, and also then write your application and CV in this kind of, you know, I can do everything mode or anything mode, the less likely it is that a company will be actually really interested in what you're doing because you don't have a specific profile. And then the one really, really pragmatic and blunt advice I have is, you want a job in the current job market, make yourself a private list of the 50 companies that you think have benefited most despite Corona. And go through that list from top to bottom. Really make yourself a list of the 50 companies. It's not the same list for all of you, because for some of you may want to work in e-commerce and they have benefited, but maybe some of you really don't want to work in e-commerce. So your list of 50 won't include those. Yeah, it needs to be your list of the 50 companies that you think have benefited in the current times that you would be interested to work for, and then really go through this. That's what I would do.
Okay, thank you. We have one more question, or if we have time for this, would be the last question because it's already past time. Lucas Schwartz, thank you. Thank you for the question. Are there many companies who have AI researcher roles? I haven't seen many job ads with this title. Is a PhD in machine learning required, or do companies also consider PhDs from other fields like theoretical physics? Okay, so I would say that for one, the title of the job can be a different one that is not exactly AI researcher. Like Irena already mentioned, maybe the title is not the same, but you can understand what the job is about from the description. And yeah.
I'm sorry. Yeah, I wanted to say that from my experience, if the job is containing a researcher, usually this would mean that, yeah, it's a person with a big academical knowledge, but also a lot of knowledge, particularly in the field of AI and data science, or at least something which is transferable. So yeah, usually the big companies have people who are doing research and making publications. So Zalando, Amazon, and Facebook. So there are people who are writing scientific articles there, and usually these will be yeah, those people.
Yeah, I would say mostly the companies or the tech companies are doing that. They have their own research team, like you mentioned, Zalando, Amazon, or Google, Facebook. They would have that. But again, then the PhD would need to be really specific in the area that they are working on. So I would say maybe not even machine learning, but let's say in NLP for working in the Alexa development research team.
Exactly. This would be one way, or otherwise, maybe somebody has a PhD in theoretical physics, then works as a data scientist in LLP and Amazon for 5-6 years, and then within the company moves as an AI researcher. So again, here internally a move would be possible. So yeah.
Yes, I would say that if you have a PhD from other fields like theoretical physics, you can still work in data, but maybe not specifically in the research area of the company, unless they're doing research in the area that you also have your studies in.
Yeah, yeah. But then,
so for example, if you have a PhD in some area that is relevant for a healthcare company, for example, that would work. I don't know.
Yeah.
I have an observation from somebody else for you on this about what's the problem in Europe. So one of the things is, if you want an AI researcher role, go to California. And why? Because actually you mentioned Alexa. So we know that there are thousands of people working on Alexa. And I had a comment from somebody recently in a German corporate who said, well, you know what the problem in Germany is? They still think that you can build Alexa with 3 people. And as long as this kind of notion persists that AI is something that you can do with a handful of people, and companies don't understand that they need real sizable teams, as long as that isn't the case, you don't actually also have the research roles, because you don't need anybody in the background that is developing the tools for tomorrow. Yeah, you need a bigger team.
Yeah.
Yes. So I just want to say thank you. Thank you for staying with us until the end. It's already 5 minutes past the time, but I think we're able to answer a lot of your questions, and the slides will be available for you, so you can take a look.
Tanya, maybe I can, because there was one question which I just saw, and since I maybe know the answer regarding computer vision, at least in Berlin, there is a great department for data visualization at Freie Universität called the Zuse Institute, ZIP, Z-A-B, ZIP. So maybe this is one to check. And there is, ZIP Berlin. So they're doing vision, and they're in Berlin, and yeah.
Thank you, Irena, for taking care of the last question. And what I want to say is, thank you for joining. Thank you for all of your questions, and please be in touch. So you can find us at the AI Guild. You can find us at LinkedIn, and we can keep answering questions or keep the conversation going there.
Yeah, thank you everyone for coming.
Thank you very much.
Staying until the end.
Bye bye.
I hope everybody enjoyed it. Bye.